Let's talk about exponent rules. Let's say you have the variable x, and that x is raised to the exponent of 3. Well, we know what that means when something is cubed. It means it's being multiplied by itself 3 times. So you have x times x times x. I'm using these little dots to indicate multiplication because if I use an x, the x and x's will get kind of mixed up. So x cubed is equal to x times x times x. If you have x squared, well, that's going to be equal to x times x, right? We've covered this before. And if you have x to the 1, that's just equal to x. So usually you don't write the 1, you just write x, right? Now, what do we notice here? Well, every time we're losing an x, or really, to go from here to here, what do? Well, it looks like we divide by x to go from there to there. And to go from here to here, it looks like we divide by x once again. And so if I do divided by x again to get to the next step, right? So 3, 2, 1 are the exponents, so the next exponent should be 0. Divide that by x. What do I get? Well, x divided by x is 1. So x to the 0 is equal to 1. That's actually one of your exponent rules that you have to remember. X to the 0 is equal to 1. Now, what if we go to the next one? So we keep decreasing that exponent. We get to x to the negative 1. Divide by x again. What's 1 divided by x? Well, just 1 over x. So x to the negative 1 is actually equal to 1 over x. That's another exponent rule. So if you have a negative exponent, it means you have the inverse of your base. So instead of x, you have 1 over x. Okay? We can take it a step further, right? You could go x to the negative 2. That would be equal to 1 over x squared. And in general, we can write just as a general form, x to the negative n is equal to 1 over x to the n. So this is kind of the general rule. So if you don't want to remember this one up here, you can just remember this general rule down here. So x to the exponent negative any number is equal to 1 over x to that number, just like that. So that's a very good exponent rule to remember. Okay, let's go on to another one. Let's say I have x to the m divided by x to the n. How can I simplify this? So, and what does this actually mean when I write this out? Well, an x here and an x here just means that we have the same base on the top and bottom. So this could be like 4 squared over 4 to the 3, or anything like that, right? So as long as those bases are the same, what you can do is you can write this as x to the exponent m minus n, just like that. This is another exponent rule that comes in very handy. If you want to see the proof for that, right, the reason why it works, if you said, x cubed over x squared, something like that, well, we know what x cubed is, right? It's x times x times x. I know what x squared is. It's x times x. Look at what cancels out here. X divided by x is 1, so those go away. X divided by x is also 1, so that goes away. You're left with x, right? What's the exponent on that x? It's 1. So all you did was you subtracted 3 minus 2 to get 1. So instead of showing that middle step, we can just remember this rule, that you can subtract the exponents if the bases are the same, and you'll end up with this as your answer, x to the exponent m minus n. Now what's nice is this also works for multiplication. So let's say you have x to the m times x to the n. Well, this is just equal to x to the m plus n. So a very similar rule, except we're multiplying now, and you add the exponents together. So an example of this, let's say you had x to the 3 times x to the 2. Well, x cubed is x times x times x. X to the 2, or x squared, is x times x. So if you multiply all these together, what do you notice? There's 5 x's, so you're going to get x to the 5. Or really what we did was we added 3 plus 2 to get 5. So once again, you can skip this middle step and just use this rule. Add the exponents together, get your final answer. So that's another exponent rule that's really helpful that you should remember. Okay, another exponent rule that we can use. Let's say you have x to the m to the n. What this allows you to do, this rule, is simplify what we have by multiplying these two exponents together. So instead of writing x to the m to the n, all you have to write is x to the m times n. So you can just multiply those together and make it into one single exponent, just like that. And a variation on this rule that I think is worth covering is if you have something like x times y to the exponent m, you can actually distribute that m into the bracket, into each of those terms, so that you end up getting x to the m times y to the m. And this also works for fractions. So if you have x over y to the m, like that, you can apply the m to the inside in the same way that we're doing up here. So you get x to the m over y to the m. So this distributive property is very, very useful for solving expressions. So that's another one that you should remember. Now let's try to do some examples, just a few quick examples. Let's say I have 3 to the exponent 27 divided by 3 to the exponent 25. Now you're probably thinking already, well, wait a second, 3 to the 27, that must be a very massive number, right? Very huge. I can't figure out what that is. I don't even know if my calculator could give me that answer. Well, you don't have to, because with the rules that we've covered, we can simplify this just by hand very quickly. So if you recall, if the base on the top and bottom are the same of a fraction, you can just subtract the exponents. So you would get 3 to the 27 minus 25. Well, what's 27 minus 25? That's just 2. 3 squared is equal to 9. Right? 3 times 3, that's what this means. That's equal to 9. So a question that looks a little bit complicated and a little bit intimidating can actually simplify itself very, very quickly. Okay, let's try another example. Let's say I have 5x in brackets, and that is being cubed. Okay, so let's try to simplify this. First, we'll distribute the 3 inside the bracket, so you'll have 5 cubed times x cubed. Okay, what's 5 cubed? 5 times 5 times 5, that's 125. And then x cubed you have to leave just as x cubed. So this is the most simplified we can make this expression. All right, let's look at another one. Let's say I have 4 over 3 in brackets, and that's being squared. What we can do is we can go ahead and distribute in the 2, just like that. So you get 4 squared over 3 squared. And then you just solve each one of these. So 4 squared is 16, and 3 squared is 9. So your answer is 16 over 9. You can verify this answer, actually, because 4 over 3 squared is another way of saying 4 over 3 times 4 over 3. And if you remember how we multiply fractions, you just multiply the numerators. 4 times 4 is 16. And you multiply the denominators. 3 times 3 is 9. So you get the same answer both ways. Okay, let's look at another one. What if I have x squared to the exponent 5? What is this? Well, if you recall, we can multiply those two exponents together. That's just going to be x to the 2 times 5, which is x to the exponent 10. That's it. Okay, let's do another straightforward one. If I have x to the 5 times x to the 3, what do I do here? If you recall, two things are being multiplied. They both have the same base. You just add the exponents. So this becomes x to the exponent 8, because 5 plus 3 is 8. So those have been some simple examples of the exponent rules and all the exponent rules that you'll need to remember. So just to review, all the rules. So if you take nothing else away from this lesson, just remember this. X to the 1 is equal to x. X to the 0 is equal to 1. X to the negative n is equal to 1 over x to the n. X to the m to the n is equal to x to the m n. X to the m over x to the n is equal to x to the m minus n. And x to the m times x to the n is equal to x to the m plus n. And then finally, x times y to the exponent m is equal to x m y m. And that also works for fractions, not just two numbers multiplied together. So if you take nothing else away from this lesson, Here are the rules. Remember these rules, practice them, and get familiar with them because they'll make your life a lot easier.